Alright, so hopefully you have one of these worksheets for those of you taking notes at home. Matter is anything that has volume and takes up space, and we just said that the two main categories under matter, which we can classify everything, is either a pure substance or a mixture. Alright. You like that little radio voice I just did there? It was very good, wasn't it? Okay, so pure substance and mixture. What I want to do now is, before we go any further, is I want the definitions. So I have this. Let us go to Josh and say, Josh, what's the definition of mixture? A physical blend of two or more components and to me, I want to underline physical. That's the key thing here. They're blended together not chemically but physically, and we've done some things physical. We've seen physical properties, physical changes. There was a word that kind of differentiated between physical and chemical. What was the word that helped us differentiate between physical and chemical? Composition is exactly what I was thinking. So physical and composition means you don't get a new composition, right? So when you mix two things together, you don't get a brand new composition. They stay their own distinct things physically combined together. And I think once we go down to homogeneous and heterogeneous, that might make more sense. The key term I like to think of for mixture, if you can use the word "and" to describe it. If you can use the word "and" to describe it, you have a mixture. Like salad is like a mixture, and we could say it has lettuce and tomatoes and cucumbers and our salad dressing. You use the word "and" to describe it. Something like more, let's say, scientific. Let's say you dissolve salt in water. You have salt and water, but we don't have a brand new thing with a new composition, if that makes sense. If you can use the word "and" to describe it. So I need a pure substance definition. Kayla, did you guys get pure substance definition?
Yes.
So matter that has uniform composition and here's where it gets tricky, especially when you got to explain it differently than, like, let's say a homogeneous mixture. Here's, to me, and this is important, I put a star next to this. Think about it. Think it must have just one chemical formula. If you can describe it with just one chemical formula, you have a pure substance. You have a pure substance. Anybody have it? To me, does anybody have examples of pure substance? Sam?
24 karat gold.
So, gold is AU, has one chemical formula. It's a pure substance. Any other ones? Christy? Glucose, C6H12O6. You can describe glucose with one chemical formula, so it's a pure substance. Nice. Anybody else? Water, H2O. One chemical formula. Hayden, you got one? Oh, you don't have one? I don't know if I'd say that. I'd say average.
Yeah.
Alright. Sabda, can you think of one? I mean, and just think of, go ahead, Fatima. I like it, CO2. Yeah. So all these, one chemical formula. So, where's that going to go next? Now I don't even know because I have the pressure of talking into the microphone. So, let us just go on to what is underneath a mixture. I'm trying.
Can we talk in the microphone?
No. But you might. So, mixture, Hayden, you can help me out with this. Give me one of the two subcategories of mixture. Homo what? Everyone says zygous. Homogeneous is correct. Your biology teachers did a good job. Homogeneous mixture and a heterogeneous mixture. Right there. So now we need the differences. Talked about the difference. How do you know if a mixture is heterogeneous and homogeneous? Let's go Sarah Anderson. Give me a definition of homogeneous mixture, please. Alright, so we have mixture with uniform composition. And there was another key phrase that I kind of liked there that the book had that I think is helpful to figuring this out. Did anyone get another key phrase for uniform composition? There was another one I liked. Go ahead, Peyton. Evenly distributed throughout. Yes, I like that. And if someone gives me a great example, we'll talk about what I mean by evenly distributed throughout. Sam, what do you got? Brass. Why is brass? Brass sounds like it should be like on the periodic table or something, but it's not. You're right. What is brass?
It's like nickel and copper.
So, metal mixtures, there's a term called alloys. Like brass, bronze, or steel. Okay. Now here's the thing I want you to think about maybe to help. First of all, there's one key word I think to help think about a homogeneous mixture that makes it different from other things. It's things dissolve in each other. If you can think something's dissolved in there, then it's going to be homogeneous, because just the fact that you've dissolved something means it's going to evenly distribute and have uniform composition. Just the act of doing that. But let's think about a chunk of brass. We've got a piece of brass here. If I take a sample from this corner right here and I compare it to maybe a sample in the middle, are they going to look the same, those samples, do you think, or are they going to kind of have their differences? What do you think? I mean, that's what I'm asking. They might be different shapes, but when you look under the microscope, the components will look just the same as any piece of that sample. Like think of, I had someone use a great example earlier, pool water. What's dissolved in pool water? Chlorine and urine and different things like that. Okay, fine. So if you take a sample of the pool at the top and a sample of your pool water at the bottom, If it's dissolved, are those samples going to look the same or different? The same. So that's going to be a homogeneous mixture. One might have more leaves, that's true. I'll actually get to something like that. I have an example to help us with that. You're right. So one might have leaves, but yeah, other than that, it's going to be homogeneous because it looks the same every time you look at it in a different spot. Let's compare that to well, actually I want some more homogeneous examples. Can we come back to that? I like it. That's going to be, I think, something in a second. All right. How about a different homogeneous mixture? Something that's dissolved in something else. Go ahead, Tessie. Olive oil. What? Salt water. Now here's the thing. She said ocean water. Let's just say salt water. We won't say it's from the ocean. We'll just say maybe dissolve a bunch of table salt in the water, because the ocean might be different. Yeah. All right. Any other ones before we move on? Jed, you got a good one?
Kool-Aid.
Kool-Aid. I like it. Kool-Aid. All right. And one last thing before we move on. There's another term for homogeneous mixture that the book had, which we're going to talk a ton about. We're going to use this term a ton. But anyone catch the word that the book said is the same thing as a homogeneous mixture? Savannah, do you happen to catch it? What is it? Solution is correct. They mean the same thing. Solution and homogeneous mixture mean the same thing. Okay. Heterogeneous mixture. Now I need a definition from Allie. So, not uniform composition. And here's what I think is a helpful thing. You will see layers, like onions, okay. You will see layers, or you can maybe not physically pick something out, but you can see with your eyes that there's a little particle right there which is different from this particle right here. You'll be able to actually kind of see to pick out different parts if you have a heterogeneous mixture. Okay. Solution or homogeneous mixture, you're not going to see different parts because it's dissolved. Okay. So what are some examples of heterogeneous mixtures? Go ahead, sir. Fruit Loops, I like. Right. What? What do you mean by pollen? I don't know what that looks like. Pollen in a flower. Describe it.
Kind of like yellow.
And it's got different particles in it? We'll put a pollen with a little question mark because I don't know, but it could be. What you would tell me is it's heterogeneous if it's a mixture and it's not evenly distributed. I'd be like, yeah, there you go. I'd be like, you're right. What you got? Why? What do you see in oil and water? Shh. You're not Kayla. She's talking. Let Kayla talk. Go ahead. The layers, and do they dissolve in each other? No. So that's how you can tell. Let's get back to Christie's ocean water. And I like to... Really?
I can do ocean water. Yo, just like karate kick it in your hand. That rings forever. Avery, this is a serious conversation. Please leave the car. Yeah, you're never getting out. You're staying with us. Hurry, lock him out. That's like not like he has keys. Really? Wait.
No, it's saying it's party at
We party at Avery's house.
Okay, Avery's on
We're gonna kick her out. That's like a new low level. Like when you get kicked out of your own house when the party's there. Like look at that guys, you're like the lowest point. You're like dial-up, and we're all like good and calling it versus that's what you're like. He's like, I'm getting my internet changed to 20 minutes. I'm like, shut up, dog. It's still gonna be bad.
Alright, so I always like to use, instead of ocean water, when I like to make the comparison, muddy, river, same thing with ocean. So think about it. We said up here H2O by itself is what? If it's just H2O, it's what?
Water.
And it's classified how?
As a liquid.
Not necessarily. As a pure substance.
Oh, that.
Alright. We said pool water was homogeneous mixture because things are dissolved in it and it's uniform. Ocean water has salt dissolved in it and different things in it. But do you think it's uniform, Christy? Do you think the top and the bottom? So how would you classify it? I agree. Are you asking me if you can see different colors throughout? That's a good. To me, if you're going to see different colors, you're probably heterogeneous because they're probably not evenly colored, if that makes sense. My guess is heterogeneous. Nice. All right, good. I like that. So we've done that. The last thing we have is under pure substance. We have two things, and obviously these are the last two that we haven't done. We have elements and compound. We have elements. We have compound. And these are things that have their own and just one chemical formula. Just one chemical formula. So let's talk about our definitions, hopefully within the next few minutes, because I got to show you an assignment. You don't have to start it today, but I want you to know about it before you leave. So elements definition, go ahead, Ryan. What's the elements definition? Alright, so did everyone hear what he said there at the end? It cannot be broken down by chemical means or chemical reactions. Ryan, do you happen to know a type of reaction that will break down an element by any chance? Anybody have any guesses of a type of reaction that will actually break an element? Go ahead, Tessie. Is she right? Peyton? Yeah, you had your hand up. Yes, you're both right. You're both right.
What did they say?
Nuclear reaction. We'll actually get to a section on nuclear reactions, which I think is really fun to talk about. Will we make nuclear reactions? What do you think? No. All right. So here's the thing. Simplest, not smallest, meaning protons and electrons and neutrons are smaller. They're parts of elements. They're things that actually make up the protons and electrons and neutrons that they know about. But a proton in an atom of, let's say, mercury is the same as a proton in a different element, let's say gold. So protons are all the same with the same properties. Once you form atoms as the one piece of an element and you build a bunch of atoms, you got unique properties then, if that makes sense. Simplest form of unique properties, not necessarily smallest. Who has an example of an element? Go ahead, Sam. Tungsten. Believe it or not, that is the symbol for tungsten. W is tungsten. Yeah, I know, like that. What do you think, Mary? What's another element? An element. Mary. Oxygen. Here's the thing, though. It's not the oxygen you breathe, but just one oxygen is correct. What do you think, Josh? Give me one more. Not CO2, because CO2 has more than one. Here, let me give you a hint. There you go. Here's the thing. You're going to see these things on the periodic table. So carbon. CO2 is an example of a compound which is two or more elements chemically combined. And you can break apart a compound